All right, let's dive into something you see every single day, but probably never really think about: mineral water. I know, it sounds simple, right? Just water in a bottle? But its story is actually way more complex. It's this incredible journey that starts deep inside the earth and ends up, right in your hand. You've totally been there. You're in a store, staring at this giant wall of water bottles. You've got mineral, you've got spring, you've got purified. What is actually going on? Is there a real, meaningful difference, or is it all just clever marketing? Well, that's exactly the question we're going to unpack today.
To really get to the bottom of it, we have to start at the very, very beginning. And I'm not talking about the bottling plant. Nope, we have to go back to a single drop of rain.
So at its core, mineral water is, well, exactly what it sounds like. It's water that's defined by its mineral content. But here's the crucial part. It's all about where those minerals come from. It's not about what someone adds in a factory. It's about what the water itself picks up on its incredibly long, completely natural journey through the earth.
Okay, so let's follow that journey for a second. It all starts as rain or snow that seeps down into the ground. Then it begins this super slow, really patient trip, filtering down through all these layers of rock. Think limestone, granite, you name it. And this process isn't fast. We're talking it could take decades, sometimes even hundreds of years. And the whole time it's traveling, it's dissolving tiny bits of minerals straight from those rocks, getting naturally enriched before it finally pools in a protected underground source.
Now, because of that super long, all-natural journey, mineral water isn't just some marketing term a company can slap on a bottle. Oh no. It's actually a protected name that comes with some very, very strict rules. And what's wild is how consistent these rules are, pretty much anywhere you go in the world. I mean, whether you're looking at the FDA in the US, regulations in the EU, or the FSSAI in India, the main ideas are the same. The source has to be geologically protected, its unique mineral blend has to stay consistent over time, and, this is the big one, no chemical treatments are allowed.
This right here, this is the golden rule. It's the most important takeaway. Producers can do some minor things like filter it or add some carbonation, but they absolutely cannot chemically change what nature has created. That rule is the fundamental promise of mineral water. What's in that bottle is exactly what came out of the ground. So all of that brings us to the ultimate comparison, right? The big showdown. How does this highly regulated, completely natural product stack up against the stuff that just flows right out of our taps? The first huge difference is the source. It's a total game changer. As we've seen, mineral water comes from these deep, protected underground aquifers, basically shielded from all the pollution up on the surface. Tap water, on the other hand, it's usually pulled from surface sources, rivers, lakes, or from bore wells, which are way more exposed to, well, everything. And here's where it gets really interesting, because that difference in source completely dictates how the water is treated. Mineral water is filtered by nature, by geology, over centuries. Tap water has to be filtered and purified by us in a treatment plant. And that process, almost always, involves chemical disinfection with things like chlorine to make sure it's safe to drink. So you've got one purified by the earth, the other purified by chemistry. To really see what this means, let's zoom in on a specific example. In a country like India, tap water is often coming from rivers that might have higher levels of contamination. That means the disinfection process has to be much more aggressive. They use things like alum to make dirt clump together so it's easier to filter out, and they add what's called residual chlorine to keep the water safe as it travels through pipes that might be leaky, which is a common problem. It's so different that in many places, the municipalities don't even guarantee that their tap water is safe enough to drink straight from the faucet. Now, all those dissolved minerals we've been talking about, they aren't just a boring detail on a lab report. No, they are everything when it comes to how the water tastes and feels in your mouth. It's what makes one mineral water completely different from another. So first up, you have calcium. This is the mineral that gives water a sense of body, a feeling of substance. If you've ever had water that felt really smooth, almost silky, or a little bit chalky on your tongue, you were probably tasting the calcium. Then there's magnesium. This one often brings a really distinct, subtle bitterness. It's not a bad taste at all, more of a crisp, sharp note that a lot of people recognize as that classic mineral water flavor. It's a huge part of the water's character. And finally, you have bicarbonates. Think of these as the great balancers. They come in and neutralize any harsh acidity, rounding out those sharper notes from minerals like magnesium, and they often leave you with this clean, sometimes even slightly sweet finish. So our water has finished its epic, century-long journey. It's picked up its unique flavor profile. Now there's just one final and super important step. How do you get it from that protected source and onto a store shelf without changing a single thing?
And this part is totally non-negotiable. To keep it free from any contamination and to guarantee that mineral makeup stays perfectly stable, the water has to be bottled right there, at the spring. This step is absolutely essential to meeting all those strict rules we talked about earlier. But even the bottle itself is a whole series of trade-offs. You've got glass, which is perfect for the water because it's totally inert. It won't react with it at all. But, it's heavy and fragile. Then there's PET plastic, which is the total opposite. Lightweight, durable, but it has the potential to leach microplastics, especially if it gets hot. And aluminum cans, they're awesome for recycling, but they actually need a super thin plastic liner on the inside, which kind of adds its own costs and concerns. There's really no single perfect answer.
So the next time you pick up a bottle of water, just remember that hidden story, this incredible journey of rain filtering through ancient rock, protected by really strict rules, all leading to a unique taste that was literally crafted by the planet. It's so much more than just hydration. It's geology in a bottle. So now that you know its story, what are you going to reach for next?